Hi, dear students. I think you all are well in this situation. Uh, Many of your exam has been completed. Many of your exams are not completed, but we cannot stop. We have to go further because you know the syllabus of class 11 is very large. Okay, so it is not like that. It is very large means we cannot able to do that. We have to complete, and you can do also that you can able to do. Uh, Not talking much, I'm just going to this subject first and what topics we will just learn. See, class 11 starts from the topic that is physical world. Okay, so physical world, you can say it is a chapter where mainly the idea from where the physics has come, from where the laws are coming, the preliminary ideas of physics have given. From chapter 1, no question will come in any of the exam, not in your class exam, your board exam, and any sort of competitive exam like NEET, JEE, main, or advanced, anywhere. It will never come. So, in generally, if you see in your school also, when it will get start, you'll see that they will start from the second chapter, unit and measurement. Okay. So, by see the name of the chapter, you can able to understand that this thing you have learned earlier also. Okay, what is unit, what is measurement, how we can able to measure it, what are different kind of unit systems are there, how many types of units are there, all that things you have remembered earlier. So for that I will not lose much time to discuss on that. So I will give one video that I have made for class 9 ICSC. They are having units and dimension. If you see that video only, units and measurements, they are also having units and experimentation. If I'm talking about the chapter's name, measurements and experimentation. So that chapter you will get the basic idea what you going to learn. But if you see your book, there are many more things are given in units and measurements. First of all, in class 11, if I want to read every part of the book, then we cannot able to complete the syllabus. That is one problem. And next problem is many more parts are given in book that is only for your knowledge. Just like the first chapter I'm talking about, that is for your knowledge. My suggestion, you should go through the part definitely, but I will not discuss this part. Similarly, in units and measurements also many parts are there which we cannot able to discuss because from there no question has come, either your board or in general school exam or in if you see in any competitive exam. So that part we will not discuss. That is the reason. Okay, like I'm given that name of the topics just like parallelix method to measure the long distance. Okay, intensity method. So these methods are there by which we can able to measure the long distances. So that one we will not discuss. In units and measurements, we will discuss three things. Number one, dimensional analysis. Number two, error calculation. And number three, significant figures. So these three things we will discuss from units and measurement chapter. Okay, so from these three, the question has come in your board as well as in any sort of competitive exam you are faced. Okay, you are going to face later. So according to the series, the first one is dimensional analysis. So for dimensional analysis only we need at least two videos to explain properly what is dimensional analysis and the numericals on dimensional analysis. And then we'll go for error. It will also take one video and significant figures. Okay, so after 3 videos, we'll meet. Okay, in any sort of online platform. And before that, we have to discuss. So today we'll just discuss the first part of dimensional analysis. I think the introductory portion I have given, it is clear enough to understand how we have to make our study forward. Okay, let's see. Dimensional analysis, that is our first discussion. So before starting on dimensional analysis, I just make you remember some easy thing which is needed. First of all, what is a physical quantity? We know the quantity which can be measured by any direct or indirect method. These are known as physical quantity. Okay, like length, mass, time, uh, density, volume, velocity, speed, anything which can be measured, that is known as physical quantity. How do you measure it? We can measure it by some unit, right? What is a unit? Unit is basically a standard physical quantity which is used to measure same kind of physical quantity. It is a standard physical quantity which is used to measure same kind of physical quantity. Just like assume we are having a scale, okay, of 1 meter long. So by using this scale, if I measure the length of a room, if it is 10 times of the scale, then we can say measurement equals to 10 meter. How we can get it? Now the quantity Q equals to N into U, where N is the number and U is the unit. So unit is your 1 meter, number how many times you have taken, that is 10. So 10 into 1 meter, that is 10 meter. It is your basic idea of unit. Okay. Now how many types of units are there? There are two kinds of units. One, this is fundamental, and another one is derived. You have learned earlier also. Okay. What is the fundamental units? The units which doesn't need the help of any another units to measure. This is known as fundamental unit. Just like if I am talking about mass, if I am talking about length, if I am talking about time, these are such kind of quantity where it not needs any another unit to measure it. To measure mass, we don't need the help of length. To measure time, we don't need the help of mass. They can be measured individually, independently. So that's why it is fundamental units. If I'm talking about the derived units, the quantity, to measure it, we need to take help from fundamental units. Just like if I'm talking about speed, talking about density, talking about power. You see, speed equals to length by time, because it is distance by time. Distance is basically a length by time. So two fundamental units are needed. It is mass by volume, and volume means what? Length into breadth into height. Okay, so it is mass by volume. Power, it is work done by time. Okay, so everywhere it needs two or more than two physical quantities to represent it, right? So these are derived unit. So that is a basic idea of fundamental and derived. Now we'll go for the dimensional analysis. What is dimensional analysis then? Dimensional analysis is basically a dimensions of physical quantity are the powers to which fundamental quantities must be raised. What is it? I'm just trying to explain it. Dimensional analysis means here we have to discuss about the power of fundamental units is used to represent a derived unit. How? Let's see. Just now we have told na that fundamental units is used in to make a derived unit. Just same thing we have taken speed, length by time. Okay. So if I represent length by L and represent time by T, okay, so we can write this one is L by T. Achha, if I have taken T at top, so it should be taken L T to the power minus 1. So we can represent speed in a form of L T to the power minus 1, and this power, okay, this power is basically the idea where the dimension of this unit is given by the help of fundamental units, right? Okay, so how much fundamental units are used to represent a derived unit? That is basically the dimensional analysis. So for dimensional analysis, what fundamental units we have taken? We have taken mass, because it is a part of mechanics. We have to use mass, length and time. So the dimension of mass is represented by capital M. The dimension of length is represented by capital L, and dimension of time represented by capital T. So by using this dimension only, when we represent some another derived physical quantity or unit, this is dimensional analysis. I am given one more example, just like density. Density is what? We know mass by volume. Okay, it is mass is volume. As a volume means what? If I am talking about the volume of a cuboid, so it is mass by length into breadth into height. See, all that things, length, breadth and height, everything is measured by the unit of length only. So these are lengths, nothing but these are only the length. So if I write the dimension of density, for mass it is M, for length L, for breadth it is also L, from height it is also L. So it will come M by L cube. See here, no T is there, but whenever we have to write it, we have to write by this way, that M means what? M to the power 1 inside the third bracket. L to the power 3 means when it will come L to the power minus 3. No T is here, but we have to write T. No T means T to the power 0. That is the dimension of density. So similarly here, speed, if I want to write the dimensional formula of speed, we have to write M to the power 0, because there is no M, L T to the power minus 1. That is the dimensional formula of speed. So here I have used one more term, that is dimensional formula. So what is a dimensional formula? Dimensional formula is nothing but the representation in a form of equation, the physical quantity of a derived one to the fundamental one. By using the fundamental units, we want to represent the derived units in a form of dimension. That is nothing but dimensional analysis. Is it clear? I think it is clear enough. And the things we have written here, these are dimensional equation or dimensional formula. Okay. Now we have to learn little bit of dimensional formulas. We have to see how many dimensional formula we can able to do. See, if you see your book, whatever the book you are having, maybe it is NCRT, maybe it is any another book, you have seen a list of dimensional formula is given. I am telling whatever the units you have learned earlier, only you have to practice the dimensional formula of that one. No need to go for surface tension, no need to go for viscosity now, because that physical quantity till now you have not learned. You will learn in class 11. Okay, so whenever you will learn, whenever you have to learn the equation of it, then it is very much easier for you to understand. Otherwise you have to memorize all the time. Okay, so that one I don't like. Next, so some example of dimensional analysis. So first we will come for force. Okay, the dimensional formula of force. So force, if I am talking about the equation, force is mass into acceleration, right? What is acceleration? We have to come step by step now. So here, to find the dimension of force, we need to find out the dimension of acceleration. The acceleration A equals to, we know na, V minus U by T, that we have learned earlier in class 9. Rate of change of velocity. Acceleration is rate of change of velocity. So here acceleration A. So we can say dimension, DIM means dimension of acceleration, that is equals to dimension of velocity by dimension of time. So what is the dimension of velocity? Another question. Dimension of velocity. We know the dimension of speed equals to m to the power 0 L t to the power minus 1. Just now we have seen. So what is velocity? Velocity and speed, dimensionally these are same. Speed equals to distance by time. Velocity equals to displacement by time. Both are length by time. Speed and velocity both are length by time, nothing else. So speed, whatever the dimension of speed, that will be the dimension of velocity. So we have to put here, so dimension of A, that is equals to dimension of velocity, that is m to the power 0 L t to the power minus 1 by dimension of time t. So when this t come upward, t to the power minus 1 and again t to the power minus 1 is coming. So m to the power 0 L t to the power minus 2. That is the dimension of acceleration. M to the power 0 L t to the power minus 2. That is the dimension of acceleration. Now if I put it here, for force, the dimension of mass, that is m, into dimension of acceleration, m to the power 0 L t to the power minus 2. M means m to the power 1. So m into m means it is m to the power 1 L t to the power minus 2. Because power, it should be added. Okay, so that is the dimension of force, right? That is the dimension of force. Now we'll come to dimension of work done. Which one is very much used, and that one you have learned earlier. That's why we have to do. Work, by which equation we can able to find the work. It is also a physical quantity. We can also able to measure the physical quantity. So work is equals to force into displacement along force. Force into displacement along force. Force into displacement along force. So if I find the dimension, so dimension of force into displacement means the length. So it is dimension of length. So dimension of force is what? M L t to the power minus 2. So m to the power 1, in the place of m to the power 1, we can write m also. It is not like that, you have to mention the power into L. So the total thing will come m L square t to the power minus 2. So this is the work done. Okay, we have done density. Now, if it is told you have to find out the power, previously we have done power equals to, we know what is power? Rate of doing work. Rate of doing work. That means W by T. So W by T means dimension of W, m L square t to the power minus 2 by T. So if the t comes, it will be t to the power minus 3. Simple thing, because when it will come, it will t to the power minus 1. When it will add, so t to the power minus 3. m L square t to the power minus 3. That is the dimension of power. So we have find out the dimension of force. Can you able to find the dimension of pressure? I am doing here. Okay. Dimension of pressure. Pressure equals to what? Force upon area. Force upon area. Area means what? If I am talking about area here, area equals to T. Length into breadth. Dimension of length into dimension of breadth. L into L. That means L square. Both the things are length. If I am talking about breadth also, it is also length. So force equals to m L e to the power minus 2 by L square. So this L will be cancelled out. So m L inverse t to the power minus 2. That is the dimension of pressure. So these are some of the dimensional formula in mechanics which is used several times for various purpose. I think it is clear enough. But now you have asked, sir, apart from this mechanical portion, this force, pressure, work, power, density, speed, displacement, time, we have learned many more things also. What are these? So we have find out heat energy. We have done earlier, if I'm going with the ICSC syllabus, we have done calorimetry, and in calorimetry there we have done many more physical quantities like latent heat, like specific heat. And the students of CBSE, those who have not learned, no problem, you will learn it in class 11. Okay, so it is not like that if you have not learned, that means you have done a very wrong thing. It is not like that. Everything it is as per syllabus. So if you have not done also, you can do it. So I think you have copied this one. Okay, so whenever you will sit, you will must sit with a copy. Otherwise you cannot able to understand what the thing is going on. And after that, whatever the doubts, that can be also discussed if you have written whatever you have not understood. Now you have to go on in heat portion, which is not in mechanics part. Okay, so how we can able to find the dimension of it? So first of all, we have to discuss about heat energy. Heat energy. How we can able to find the heat energy? The heat energy is nothing but a form of energy, right? Heat energy is nothing but the form of energy. If I find the dimension of energy, that should be same with the heat energy. If we find the dimension of heat energy, dimension of energy, that should be same with the heat energy. So from here we have to find the unit of energy, a dimension of energy. We know work and energy are equivalent. Work and energy are equivalent. So equivalent means, I think you have seen this sign in chemistry, means how much energy you are having, you can able to do that much amount of work. or in another way, how much work you have done on a body, that can be stored as a form of energy on that body. So these are equivalent. So if I found the dimension of work, that should be same with dimension of energy. So dimension of work, we have find it out. So E equals to m L square e to the power minus 2. That is the dimension of work. See, whenever we are talking about the dimension, we have to put it in third bracket. Okay, that is needed. In some book you can see it is written in third bracket. In some book it is not written. No problem. We have to write it down. Okay. This is the dimension of heat energy. Okay. Now I am coming to latent heat or latent heat capacity. Latent heat capacity, which is denoted by L. No problem if the student of CBSE, they cannot able to understand from where the latent heat has come. I know you are familiar with the term, but you are not familiar with the equation. No problem. You will just know in this year only. Latent heat, this equation, if I am talking about, that H equals to small m into L, where H is the heat energy, m is the mass, L is latent heat capacity. Okay, ICSE students, I think they can easily correlate. Okay, and one more thing I can make you clear here. The syllabus of CBSE, ICSE, West Bengal board, whatever the board it may be in India, all are same. The physics syllabus is same for any board. Okay, maybe the names and the chapters are not arranged in same book similar way, but it is same. Okay, so no problem with your CBSE or ICSE or West Bengal board, whatever it may be, it doesn't make any problem. So from here we have to find L. So L equals to H by M. So dimension of H we know, that is m L square t to the power minus 2. Dimension of m, it is m. So this m cancel out, so it should be m to the power 0 L square t to the power minus 2. That is the dimension of latent heat capacity. Okay. Now one more thing we have to do. There you will understand that only mass, length and time, it is not enough to represent a dimension. Just like if I am talking about specific heat capacity, I think the ICSE student can relate with me. You have just learned this thing. Specific heat capacity. Specific heat capacity, we know the heat absorbed by a body, if it is H, that is equals to ms del T. Okay, what is m? M is the mass. What is s? S is specific heat capacity. What is del T? Del T is change in temperature. Okay, so if I find S equals to H by M del T. So dimension of H we know, it is written here. M, that is also we know, but del T, change in temperature, we don't know. We don't know the dimension of temperature. So what can I do? For that, the unit of temperature, that sign is taken as its dimension. So it is written dimension of temperature, that is K. We all know the SI unit of temperature is Kelvin, that is denoted by capital K. Here also that capital K is taken as its dimension. Okay, no problem. So we have to write it down. So S equals to H means m L square t to the power minus 2 by m del T K. Change of temperature means dimension should be K. Cancel out. m to the power 0 L square T to the power minus 2 K to the power minus 1. This is the dimension of specific heat capacity. This is the dimension of specific heat capacity. So what we have done? Nothing. We have just made the unit of temperature as its dimension. Okay. That is the dimensional analysis of heat. But apart from heat, one more type of quantities are there. That is electrical measurements. We have done many more electrical measurements. We have done measurement of current, measurement of potential, measurement of charge. Many things we have done. So what should be the dimension of them? Let's see. Okay. So dimension of electrical energy. Dimension of electrical energy. So if I am talking about the dimension of electrical energy, we all know all the energies are same. What is the dimension of heat energy? It will be same with the dimension of electrical energy, nuclear energy, any mechanical energy, any energy, that dimension should be same. If I am talking about the electrical energy, that will also m L square T to the power minus 2. That is the dimension of energy. Now we are coming to the dimension of charge. Okay. See, we cannot able to take any alphabet as a dimension of charge. What we can take? See, in class 9 only, you have learned, I'm talking about ICSE students, they have learned about units and measurements in measurement experimentation chapter. And there in fundamental units, you have seen that current electricity or current is taken as a fundamental unit. Okay. So whenever we have to represent the charge, we can take help from current. And now the another students of CBSE, they thought that we don't know. No problem. The video, whatever I will send it to you. Okay, I have told me I will send a video of class 9. Then there you will clearly understand what I am talking about. So dimension of current is taken, and that is taken as per its unit, ampere. That is known by everyone. That is the unit of current, and that is been taken as the dimension of current, A. And charge equals to, we know, current into time. So dimension should be, if I am talking about current, it is A, time equals to T. So A into T, that is the dimension of charge, Q. Dimension of charge. We can mention here m to the power 0, L to the power 0. Okay. But if you have not mentioned also, it doesn't make any problem. Okay. If I am talking about potential, electric potential. Though there are several equations to find out the electric potential, but the very common one, the first one we have learned, that it is basically work done per unit charge, V equals to W by Q, work done per unit charge. So we know the dimension of work done, that will be the dimension of energy, m L square T to the power minus 2. Dimension of charge, A T. So here it will be m L square, when this T will come up, T to the power minus 3, A to the power minus 1. That is the dimension of electric potential. If I am talking about the dimension of resistance, so resistance equals to what? V by I, as per Ohm's law. I think you can remember what is Ohm's law. Just this year only you have learned. Okay, so V by I, so V equals to m L square T to the power minus 3 A inverse and I equals to A, it will come up. Okay, simple thing, it is m L squared t to the power minus 3 a to the power minus 2. That is the dimensional formula of resistance. Okay, now from the first only you have just thinking why SAD is doing this one. We know the unit, we know the physical quantity. What is the use of learning this dimensional analysis? What will happen if I find the dimensional analysis of power or force or electrical resistance? What extra help we can get from this dimensional analysis? That whatever the things we are doing, definitely there should be some logic. Without logic, if I have done something, that means that is a useless work. So why we have to do the useless thing? We must do the use of dimension. So our next part is the use of dimension. Okay, why we have learned the dimensional analysis? What is the need of it? Let's see. So we can write down application of dimensional analysis. Application of dimensional analysis. Okay, what are the application? We use the dimensional analysis for 3 reasons, because it have 3 application. In some book it is written 4, but generally we have used the 3 applications. What are the 3 applications? Number 1, we need to convert the one unit system to another unit system for a physical quantity. We have done that. We are finding out sometime 1 kg equals to 1000 gram. So kg, it is in a unit system, gram, it is a unit system, it is SI, it is CGS. So to convert the physical quantity in different unit system, we need to take the help of dimensional analysis. So first one, to convert a physical quantity to convert a physical quantity from one system to another. Okay, so let's see an example how we can able to convert it. See a example here. We all know if I am just writing a physical quantity Q, that is equals to N into U, where N is the number and U is the unit. But if I am taking different unit system, we can write it N1 U1, N2 U2. Why? Because the physical quantity I have taken, it is constant. Assume it is 1 kg of salt. So if I have taken in SI, the value of N is 1 and unit is kg. So that's why N1 U1. Whenever we have taken to CGS, the value of N is changed. That's why I have taken N2 and the unit is gram. That is also changed. So if a constant physical quantity I have taken, for that N1 U1 should be equals to N2 U2. Now if I want to find the relation between CGS and SI unit of force. We know CGS unit of force is dyne, SI unit of force is Newton, and we know the relation also. Same relation we have to find out by dimensional analysis. Sorry dear students, due to some technical error, the video has been disconnected, so that's why you cannot able to do the next one. So I'm coming to the portion where we have discussed. See, we are discussing about the application of dimensional analysis. There we have seen how one physical one unit from a physical quantity to convert to the another. So here our target is to conversion of the unit of force from CGS to SI. So we all know that unit of force is dyne in CGS and Newton in SI. So that conversion we have to make. Assume these two equations are there. N1 U1 is equals to N2 U2. The value of N1 and N2 we don't know. So U1 is a unit and U2 is the unit of another what we can say, another unit system. Let's U1 is for CGS and U2 is for SI. Now we can put the dimensions because we have just read the dimension. So what should be the dimension here? For U1 we can write down N1 L1 T1 to the power minus 2, because we know the unit of force that should be ml t to the power minus 2. So as it is for unit 1, so we have written m1 l1 and t1. N2 it is m2, sorry, that should be in capital, m2 l2 and t2 to the power minus 2. Okay, so these two unit systems are there. Here we want to find the relation between N1 and N2. We want to find out that. So from here N1 equals to N2 into M2 by M1 into L2 by L1, and here T2 by T1 whole to the power minus 2. Okay, so up to this I think it is clear enough for you. Okay, now you see these are the mass. This is the mass in SI unit, this is the mass in CGS unit. So what should be the relation? In M2 we know M2 equals to what? M2 equals to 1 kg, M1 equals to 1 gram. So M2 by M1, that is 1 kg by 1 gram, that is 1000 gram by 1 gram, that is 1000. Similarly L2 equals to 1 meter, L1 equals to 1 centimeter, L2 by L1, that is 100 centimeter by 1 centimeter, that is 100. And you see T2 and T1 both in CGS and SI it is second. So no need to make any conversion here. Okay, no need to make any conversion. So here we can write N1 equals to N2 into 100, 1000 into 100. And T2 by T1 it will be cancelled out because T2 and T1 both are second. So it is 10 to the power 5, N2 into 10 to the power 5. So if N2 is taken as 1, if N2 is equals to 1, then N1 equals to 10 to the power 5. So N1 you see, it is the CGS one. So from here we can conclude 1 Newton, that is N2 we have taken 1, equals to 10 to the power 5 dyne. That is proved. Okay, so this is the proof where we have seen the conversion is occurred between the unit of force CGS to SI, and that can be done through dimensional analysis. Okay, now we'll see what more thing we can able to do from dimensional analysis. So please copy it. I think this one is very much important for you. So these are the examples. After that we will practice numericals on that also. Next, so next part is what? Next part is that by using dimensional analysis we can able to test whether equation, we have written many more equation in physics, na? We can able to write down the equations are right or not. So our next target is to check the correctness of a physical equation. Any physical equation, whether it is correct or not, how we can able to understand. See, if in equation, you know, one side is LHS, another one is RHS. So if the dimension of LHS should be equals to dimension of RHS, then we can say yes, the equation is correct. And if the dimension of LHS and dimension of RHS is not same, then we cannot say, we say that the equation is wrong. Let's see an example. Very common example. We know one equation of motion, that is S equals to ut plus half at square. This is a very common equation, we all know that. Now we have to come here. Dimension of LHS. What is this? S is displacement. So dimension is the dimension of displacement, that is L. So we can write m to the power 0, L to the power 1 and t to the power 0. That is the dimension of S, because it is the length only. Now if we find that this dimension is also giving the dimension of length, then we can say our equation is correct. Let's come. Dimension of RHS. First part, u into t. What is u? We all know that it is initial velocity. Initial velocity. So initial velocity means m to the power 0 L t to the power minus 1. Because velocity v equals to, we all know, L by t, that is LT inverse, and here we have to mention the mass also, that is m to the power 0 into t, time, minus 1, this is plus 1, minus plus 0, so it is m to the power 0 L t to the power 0. If I find the next part, that is half a t square. Now I am coming to the half. See, for half there shouldn't be any sort of dimension. Half is a number. So here no dimension for half. We have to come to the dimension of A. Dimension of A we know, that is m to the power 0 L t to the power minus 2 and t square into t square, and again it will come m to the power 0 L t to the power 0. You see, as it is added, these two dimensions are same. So the dimension of RHS should be m L to the power 1 or L t to the power 0. And here also it is m to the power 0 L t to the power 0. In both sides you see the dimension is same. Now some problem you may have, that sir, this is L and this is L, when it is added it may be 2L. No, because here we are finding the dimension. If it is L and if it is L, if there is a minus sign also, the dimension will be L, because we can add or we can minus only that quantities which are same. We can minus length from length, we can add mass to mass, we can add volume to volume, but we cannot add mass to time. Can we able to add? We can add mass plus time, we cannot able to do. So as these two quantities dimension are same, so the whole dimension should be same. Okay, no numerical value should be taken. So as the two dimensions are coming same, we say that yes, this equation is correct. This equation is correct. Okay, so by this dimensional analysis, we can able to check the correctness of a physical equation. Okay, number 3. Okay, so I have told you to tell number 3 application of dimensional analysis. So number 3 is the most important application of dimensional analysis. It tells us that if we know the dimensions of two quantities, we can able to find the relation between them. What is that? Now by the dimensional analysis, we can find the relation between two physical quantities. How? So first we have to write the heading. Okay, what is the heading? To derive the relationship between different physical quantities. To derive the relationship between different physical quantities. Question has come, how? Okay, how? So it's a part of trying. No, we'll not try. We'll see what, by which method we can able to find the relation. Assume one example is given to you, that centripetal force. Now one thing I mentioned, by the name, the students of ICSE board, they can relate themselves, but CBSE maybe they cannot able to relate themselves. No problem, I'm telling you again, this term also you have to learn in class 11 again. So for yourself, it is simply a force which is generated in uniform circular motion. Uniform circular motion, you know, if a body moves in a circular path with a constant speed, that type of motion is uniform circular motion, and there one force is generated, that is centripetal force. It tells us that centripetal force depends on mass, speed and radius, speed of the body and radius of circle. What I'm telling, that centripetal force, this is one kind of force which depends on three things. First one, 1 minute. So there is a problem I have seen in the video. Wait a minute. I think it is clear enough. Okay, thank you. So centripetal force depends on mass, speed and the radius. Radius means this one. So mass, it is the mass of the body. Speed, on which speed it is rotating, assume it is v, and the radius is r. So it tells us it depends on these three things. How it depends, in which equation, we don't know. So how we can able to find the relation? So to find the relation, we'll get a help from dimensional analysis. How? Let's see. So here it is told, force or centripetal force is depending on mass. How it depends, we don't know. So then everybody will ask, sir, why it is written m? We'll not write m, we'll write m to the power a. So now you may ask, sir, it may be inversely proportional also. Yes, it may. So the value of a should be negative, then it will be inversely proportional. If the value of a is positive, then it will be directly. Okay, so we will assume that Fc is directly proportional m to the power a. Not only that, Fc, that is centripetal force, Fc means centripetal force, is directly proportional to the speed. How? Now by the power of b. And if C is directly proportional or is related with the radius. How? Now with the power of C. Whether we know what is A, what is B, what is C? No. We don't know what is the value of A, B and C. So we have to mention here A, B, C are constant that we don't know. If we write it together, so FC proportional to M to the power A, V to the power B, R to the power C. If I find the value of A, B and C, then easily I can find the relation, but it is a proportionality sign. So before that we have to make an equation. So what should be the equation? We have to give a constant here. We know to convert proportionality sign to equal sign, we have to give a constant, that is FC equals to K into MA VB RC. Okay, and this K, whatever the things we have taken, that is a dimensionless constant. K is dimensionless constant. What is dimensionless constant? That also I make you clear. Dimensionless constant means it is a number only. It is only a number. It doesn't have any sort of dimension. Means its dimension is 1. Dimensionless means dimension is 1. It is a number. Okay, so let's go. As I am telling, this is the equation, you see. So as per the previous part, in the part 2 we have seen that if it is the equation, so dimension of FC should be equals to dimension of this. Dimension of FC should be equals to dimension of this. So we have to write as it is a equation, so dimension of FC should be equals to dimension of K M to the power A, V to the power B, R to the power C. Okay, so both the dimension we have to find out. Okay, let's see how we can able to do it. So this part here it is been over, so we'll go to little up so that we can able to do that. Okay, maybe it seems to be little harder, but just see it properly. I think it will be very much easier for you. So dimension of FC, I have written here dimension of FC. What is it? It is a force. So dimension of force we know mL T to the power minus 2. That is the dimension of force. We have already learned. Dimension of this one. So dimension of K M to the power A, V to the power B, R to the power C. So K, it doesn't have any dimension. For M, it is M to the power A. V means L T to the power minus 1. Definitely there will be a M to the power 0. Wait, place is there. Okay, M to the power A into, for V it is M to the power 0 L T to the power minus 1 whole into B. For R it is a distance, so M to the power 0 L T to the power 0, that to the power C. Again, for mass I have written only mass. Okay, so if you want, here also you can written M to the power M L to the power 0 T to the power 0 whole to the power A. You can write by this way also, don't problem. Okay, it is not like that you have representing the dimension. Here simply you have measuring, so whatever the zeros are there, that you can abolish also, no problem. So if you abolish, it will come M to the power A, and here you see L to the power B, and here L to the power C, right? So L to the power B plus C. Okay, T to the power, you see minus B. Any more thing is there? T to the power minus B only. T to the power minus B, nothing else. Okay, because here A to the power it is 0, cancel out, it is also 0. So this will come. Now, if it is a equation, so the dimension should be same. So, dimension of LHS, if it is equals to dimension of RHS, then the power should be same. Power means this A, B plus C minus B. This power should be same with this. Here you see m to the power 1. Nothing means 1. So here we can say m to the power A. Here it is m to the power 1. So just comparing this two, we can write A equals to 1 by comparing this number 1 and it is number 2. Now for L, B plus C. So here B plus C, that is equals to 1. L to the power 1, here it is B plus C. At T to the power minus B. So T to the power minus B means, so minus minus cancel out, B equals to 2. You see, B equals to 2. Clear? Now we have to find the values. Okay, we have to find the values. If these things are same, then we have to find the value of C. So what is the value of C here? C equals to 1 minus B. 1 minus B means 1 minus 2. So it is minus 1. Right? Now we put the values of the equation. In equation, whatever the things we have assumed. See, very easy thing. Now, FC equal to K m to the power A. M to the power A means 1. V to the power B. V to the power B means 2. R to the power C. So R to the power C means minus 1. Okay, and we can write it that FC equals to K m V square by R. K m V square by R. And now from here, if m comma V comma R all are equals to 1, that means m equals to 1, v equals to 1, r equals to 1, if we have taken, then Fc is equals to 1. Means if mass, speed and radius is 1, then your Fc, it is also 1. So here if I put the value k equals to 1. So k is a constant whose value is 1. So the equation Fc will be m v square by r. That is the equation we have found by dimensional analysis. You see, by dimensional analysis we can able to find this equation. Now we'll just go that many more constants we have seen now, this k. Okay, so some of the constants are there, we can able to find the dimension of the constant also. So if I am talking about the constant, there are two type of constants in our physical equation. So I think I can able to remove now. Okay, if you want to write it, so make your video pause here, write it down, and then we'll go for the next one. Okay, so what is the next thing we'll do? So next thing means we can say it is the last part of the dimension. From next day, okay, we will do the numericals of it, as well as one part I will left, that is the limitation of dimensional analysis. Though there are many more uses, but there are some limitations. So constants. So in physical equation there are two type of constants are there. One is dimensional constants and another one is dimensionless constant. just now whatever I have seen, K is a dimensionless constant. K is a dimensionless constant. Not only that, in mathematics many a time we have used pi. It's a number. Exponential E is a number. So they are not having any dimension. But in opposite side, if I'm talking about gravitational constant, capital G, Planck's constant, that you will come to learn in class 12, Boltzmann constant, okay, all these are having constant and their dimensions also we can able to find out. So today's last work is to find the dimensions of any of the constant. So I'll give you an example, only an example I'll give, and then today's video will be over. Okay, what is the example? Let's see. Assume if I'm talking about gravitational constant, we know gravitational force F equals to G m1 m2 by r square, that we all know, na? Okay, Newton's law of gravitation. It's a very common thing. From here, if I find G, F r square by m1 into m2. Now from here, if I want to find the dimension of G, so it is dimension of F, that is m L t to the power minus 2 r square. R square means what? L square. Then m in m1 into m2, masses m square, and see m will be cancelled out. Okay, so the answer will be m inverse L square and L cube t to the power minus 2. So this is the dimension of the gravitational constant. So we can find the dimension of some constants also, whose dimension we can able to find. These are, we can say, dimensional constant, whose dimension we cannot able to find. These are dimensionless constant. So today's work is done. My suggestion is go through the book, the portion I have make you read here, only that one you will read. Okay, many more things are there in units and dimension. If you are just put there, if you just go there, you cannot able to complete. To complete this chapter only will take 2 months. So it is not needed. Which one the important parts are there? I am just showing you that portion, and if you go through this one, it is enough for you. And along with that, another video will come in between 2 or 3 days for dimensional analysis. There we have discussed about the limitation and some important numericals. Okay, so before that, just go through it. Thank you.